Yes, good morning, everyone. Yes, today we are with our teacher. Our teacher is Lindy, and she's going to be introducing herself to us. And then after, she'll be taking us through a new topic of mathematics. And after, we shall have some exercise. So allow me to invite Lindy to introduce herself, and then she introduces the topic. Lindy, you're welcome.
Yes, hello everyone. Good morning. So, my name is Linda, and I will be teaching you guys the first start of the new chapter 3. So, I'm really excited, and I hope you guys um, are excited as well. So I will start sharing my screen so you guys can see what I prepared for you. And if there's anything unclear or I go too fast, you can always tell me. You just raise your hand, or yeah, I think Stefan can put on his mic and he can tell me I'm moving too fast, but I will try to go as slow as possible and get all you guys in my presentation. So I hope that works. So I will start by sharing my screen like this. Can everyone see it? Okay, perfect. So as I already told you guys, we're going to start on a new chapter, specifically chapter 3 on fractions, percentages, and decimals. So let's dive into it. I will go over a brief introduction of what we will see today. So we will start on an introduction of, first of all, what is a fraction? I think that's quite important. Then we will see the different types of fractions. We will see 3 types specifically, namely proper fractions, improper fractions, and equivalent fractions. And then we will do some exercises together through a Kahoot quiz. It's something that looks similar to a quizzes, but it's a different platform. It's something I love to use, so I hope you guys will love it as well. It's in a form of a multiple choice. So you guys have to pay attention throughout the lesson, and then you will be able to do all the exercises very well. And then we will draw a little other exercises on the screen, but that's for the end of the course. So if we have some time over, but I think this will be sufficient for today, we can also start on converting the improper fractions to mixed numbers and vice versa. But as I already told you guys, I think we will just do 3.1 for today. So for the introduction, I brought a nice picture. It's a picture of a pie, as you might can tell me. And we see that the pie is divided um, into different pieces. Specifically, we see that one piece is already cut out, so one piece has been eaten up by someone. And we notice that there's still a quarter and a half of the pie left. So that means if we multiply the quarter plus the half of the pie, so the total pie that is left, we have 3/4 of the pie that is still left and still ready to be eaten. So that's an example of a fraction and an example of how we can use fractions. But we will dive into it a little more so you guys can explore what fractions really are. First, an example. So a basic example of any fraction could be 1 on 2, 1 on 4, 4 on 4, or even a larger number, 1,324 on 265. So those are examples of fractions. I think you all have seen something familiar, so I hope it's not looking that weird, but we will dive into it more and we will explore what
Lindy? I think we have lost her. Let's give her some time. But those who can't,
Okay, sorry. I noticed my connection. There was something wrong with it, but I hope I can just restart. Oh, okay. Sorry. My internet just went out of the window. So I will continue where I left. I hope you can see my slides again. Okay, so we were discussing the general form, where we had a general form looking like A, and then we had a dash and then a B. So where A and B are represented as whole numbers. And my question to you guys was, do you remember what a whole number is? Yes. So can someone repeat what a whole number is or what it contains?
anyone? Yes, you can come around. Yes, you can tell us. Yes, you can tell us. Yes, someone tell us. Yes.
Whole numbers are similar to natural numbers, but include zero.
Linda, are you able to hear?
Nah, not really, but I'm trying to.
Okay. She's here.
Mm-hmm.
Whole numbers are similar to natural numbers, but include zero as well. For example,
Yes.
0, 1, 2, 3, 4, and
Okay. Yeah, perfect. That's indeed what a whole number is. So it's a collection of all the natural numbers, including zero. And that means that there are no decimals or no fractions involved. So A and B are both whole numbers. And I also have mentioned that B can never be zero. Does anyone has an idea why B could never be zero? Perhaps that's a little more of a difficult question.
Anyone who can tell us, you can come here. Come.
You can just try it. It doesn't matter if it's wrong. I love when you try to come up with an answer or an idea.
Yeah, because like if like 4 over 0 is basically 4 divided by 0, and any number divided by 0 is 0, so that number will just be 0.
Mm-hmm. That's an interesting thought indeed. The thing is, with division, it's actually the reverse of multiplication. And we all know that if we multiply something by 0, we always end up with a number equal to 0. We can never multiply, for example, 4 with 0 and become 4. It will always be equal to 0. So it means that if we divide something by 0, it's not possible. So that's something really important to remember in mathematics. You can never divide by 0. So I hope that's clear for you guys. And then we will continue. Okay, so this is a general form, but we will zoom in into more details now. So the top number A, we will call the numerator, and the bottom number B is called the denominator. So those are two terms you guys need to remember. And if I'm talking about a numerator or a denominator through the rest of the presentation, you always have to think back, okay, the numerator is the top number, the bottom number is the denominator. Okay. And then we have also the simplest form, or also called the lowest term. And it means when the top and the bottom cannot be any smaller. I see I have a little spelling mistake. I'm sorry, but it's because my presentations are always made in Dutch. So sometimes it changes itself to Dutch, but it's meant to be an and. But I hope you can read it still. So we will zoom in a bit more on the simplest form, since I expect you guys to be able to change a fraction from a not simplest form to a simplest form. So I have already a small example. First of all, we see that a fraction 1 on 2, that is the simplest form, but 2 on 4 is not. And why not? You can see it right here. So we see we have a pie. The pie is on both sides, it's equally big. And the first pie is divided in two parts. So we have part 1 and part 2. And only half of the pie has been eaten. So it's half of the pie, it's 1 on 2 that has been eaten. The second pie is not divided in two pieces, but in how many pieces? Can anyone tell me?
You can talk.
4, indeed. So the second pie is divided in 4 pieces. And how many pieces have been eaten of the second pie? 2, indeed. But are these pieces the same amount? Did the person that ate the first piece of the first pie and the 2 pieces of the second pie, did he eat the same amount? Yes, indeed. We see that although the first pie was 1 piece and the second pie ate 2 pieces, that the amount is the same. We see it's the half of the pie. So in this example, 2 on 4, 2 pieces of the 4 pieces is the same as 1 piece of the 2 pieces. Do you see that? So the simplest form is where the A, so the numerator and the denominator are the smallest possible. So in our example, it's the 1 on 2. I hope that everyone understands that. But I have another example for you guys to make it even a little bit more clear. So let's say you throw a party and you invite 12 people over to join your party. And you also provide a cake, a pie for everyone to enjoy. So in how many pieces would you cut the cake if you know that there are 12 people coming?
We beg your pardon?
So we have 12 people joining our party and we bought one big pie for everyone. In how many equal pieces would we cut the pie so that everyone can enjoy a piece of the cake?
This was the answer. We can say it together.
12, indeed. So we will cut up the cake in 12 equal pieces so that all of our friends can enjoy the cake. But imagine that only 6 people showed up to your party, but they were very hungry. So all of them ate the whole cake. The whole cake was empty. The whole cake was eaten at the end of the party, and every person at the party ate the same amount of the cake. So how many pieces does everyone eat? Two pieces indeed. So now we can say that all people ate two pieces of the 12. So that's 2 out of 12 pieces. But we know that if we were to throw the party with only 6 people, knowing it in advance, and we were to cut the cake, would we still choose to do it in 12 pieces? No, indeed. How many pieces would we pick if we know that only 6 people showed up? 6, indeed. We will choose to slice the cake in only 6 pieces. So we know that if we divided the cake in only 6 pieces, how many pieces would everyone eat? 1, indeed. So if we knew this, you would have cut the cake differently, so into 6 pieces, so that everyone only eats 1 piece out of the 6. And it's the same amount as 2 out of the 12, but it's of course less work for you to cut a piece in 12 pieces, to cut the cake in 12 pieces. So I hope to you it's more clear now what it means to have the simplest form, because 1 out of 6, it's the lowest possible number. While we know from 2 out of 12, we can make it lower. We can divide both by 2, because we know with a fraction that we have the thing we do at the top, we also have to do at the bottom. So I will continue. So we have a certain method to use to know when we have the simplest form. So what you do in the top, in the numerator, you also have to do in the denominator. That's the rule in fractions. When you multiply with 2 in the top, you have to multiply with 2 in the bottom. That's the most important rule. So then we're going to determine the greatest common denominator and divide both the numerator and the denominator with it. Can anyone repeat to me what the greatest common denominator is?
Yes, you can tell us.
The greatest common denominator is like the LCM of the two denominators.
Have you got that thing?
Yes.
Okay.
Linda, did you get the response?
Not completely. I heard parts of it because it was a little far away, I think.
Let him come here. He's coming. Let him tell us what he thinks.
Yeah, perfect. Yes, perfect.
The greatest common denominator is the LCM of the two denominators.
The LCM, what does that mean?
The lowest common multiple.
The lowest multiple. Okay. I'm trying to translate it in my mind. So the greatest common denominator, if for example, I give you the numbers 4 and 6, what would be the greatest common denominator?
It would be 20. 24.
20. 24. Okay, so I think I mean something else. I mean for 4 and 6, you can divide both by the greatest denominator. So you can divide both by 2, for example. So you can divide 6 by 2 and you can divide 4 by 2. And then you will have 2 and 3. So the greatest, I don't know if I translated wrong, but so the greatest common denominator, what thoughts were, is that you find something to divide it, so they're both dividable by a certain number. So in this case, 4 and 6 are both divisible by 2. Okay, but we will see an example really shortly after. So I hope it will all get clear. So we will divide the number we find by both the numerator and the denominator, and we will repeat this process until we can't go any further. Here I have an example for you. So let's say we start with a fraction 4 on 8. So 4 is our, can anyone tell me how can we call 4? Yes, the numerator, and 8 is denominator. Perfect. So we have 4 on 8, and we want to make the simplest form. So we're going to search for the greatest common denominator. And in this case, we know that 4 and 8 can be divided by 2, and it's the biggest number that's able to be divided by both of them. So we will divide 4 by 2, and we have to do the same in the top and the same in the bottom. So we will also divide 8 by 2. So dividing 4 by 2 will give us 2, and dividing 8 by 2 will give us 4. And then we will 2 out of 4. We can do that again. We can restart the process and find something. We have to find a divider of the 2 and a divider of the 4. So it will be dividing 2 gives us 1, and dividing 2 at the bottom gives us 2. But I made a small mistake. I could have moved faster because I told you guys it's the greatest common denominator, but actually it isn't. The greatest common denominator of 4 and 8, does anyone have an idea?
Yes, stop.
4, indeed. So we could have divided by 4 both parts. So we could have divided 4 by 4, and that would give us 1. And we could divide 8 by 4, and that would give us 2. So that will have the same solution as we found through this process. So when you see a fraction, you can look for something you can divide with the top part and something you can divide with the bottom part, and look for the greatest option. So it's the easiest way to go to the simplest form. I hope my explanation was clear for everyone. Or are there any questions?
Question? You can come. There is someone with a question.
Okay, perfect.
What if we have like big numbers?
Mm-hmm.
Do we have to divide them by 2? Will that take long?
Yeah, that would take long indeed. But if you have really big numbers, you can start dividing by 2. You can start just dividing by 2 a couple of times until you perhaps see something else that is in common and find a way to divide it that way. But in general, we won't have really big fractions. We will use the smaller fractions, but indeed, it would take a long way to make it the simplest form. But the best trick to do it as fast as possible is to look for the biggest common denominator. For example, 2 is a really small denominator, but if you can find number 8, if both numbers are divisible by 8, you should pick 8, because then you have to divide by 8, and then you will already have a really small number.
Thank you.
Okay, perfect. An example would be 8 on 64, because we know that 64 is divisible by 8, and 8 is divisible by 8. So if we divide by 8, we will already have 1 on 8. Okay,
Yes.
perfect. Okay, so this was the introduction, and I hope you guys now have an idea of what a fraction is and how it looks, what it looks like, and what we can do with it to make it the simplest form. And then now we will move on to some specific fractions, so some types of fractions. The first one, so on the left side, you see the general form. It's just for you guys to make it clear. We always have two whole numbers, A and B, and we have B never equal to 0. So still remember that, that's the general form of a fraction. So now we will zoom in on what a proper fraction is. A proper fraction is a fraction where the numerator A is less than the denominator B. So can anyone come up with an example of a proper fraction? There are many choices, so almost no wrong answers.
2/5.
2 on 5, perfect, 2 over 5, because 2 is smaller than 5. Another example? There were two.
1 out of 4.
1 onto 4, yes, perfect, indeed. Oh, perhaps you should. Yeah, okay, that's better. So indeed, those are examples of proper fractions. I also wrote down 2 examples, 3 out of 4 and 7 out of 9. So now we're going to make a small exercise. I brought again a pie with me. And now it's up to you guys. I don't know if it's possible for you to draw on the screen. And I want to ask you to shade 3 out of 4 pieces of the pie. So I don't know, the people that are in the Zoom call, if anyone can draw on the presentation, if that's possible.
Yes, let us try.
Okay, perfect.
Now, screen. Try to do. Now go to where you have view option and then click that button and say annotate.
Yeah, perfect. I see Adrian already.
Let me.
Perhaps you can make your tool a little bigger so you don't have to draw with all the small lines. But you can also just make some lines across and make it visible where you want to shade the pie.
Yes, I saw people were annotating. Please go on. Go here where there is view up. Yes. Please annotate.
Oh, now we have a big part of the pie that is covered. So perhaps work a little together and try to shade only 3 out of 4 pieces. Okay. So I notice already 1 piece is shaded. Is that sufficient? Oh, okay. Okay, but I think we have an idea of how many pieces we would like to shade, right? Okay, now the whole pie is shaded, so we will remove the current drawings and I will, so you guys can stop drawing. It's fine, thank you so much. I will just make one general drawing so we're all on the same page. In my opinion, 3 out of 4, so we have to do 1 piece. We will do another piece. Yeah, I'm not really filling it in correctly. And then a last piece like this. So this would be all filled in and all be shaded. So that means that only one part of the pie will be left over. So if we were have to imagine a fraction 3 over 4, we would notice and we would see something like this. Okay, so now the next fraction I will, so the next fraction is a fraction and you guys have to shade 7 pieces out of 9. And this time I didn't brought a pie, I brought a certain pyramid. So now it's up to you guys to fill in 7 out of 9 pieces. Yeah, perfect. That's a great way to do it. That's fine. You don't have to fill it in completely. If we can note it, if we can see what you did, then it's fine. Okay, so you already have 2 pieces filled in, 3 pieces, 4, 5 pieces. It's going fast. Now it's gone again. Okay, very well. So, okay. Yes. Okay, perfect. Now someone else is, Alicia is shading as well, but I think we already. Aha, perfect, indeed. Okay, so now 7 of the 9 pieces are covered. So 7 out of 9 are shaded. So that's very well. So I hope you all have uh, an image of how something can be shaded and what it looks like. So in a proper fraction, we will always have a figure, but it won't be completely shaded since the numerator is smaller than the denominator. So in our example, we know we need 3 pieces out of 4, so 1 piece will be left over. And 7 out of 9, so we know 2 pieces will be left over. And that's very important to remember because that will be different when we go to look at improper fractions. So I will remove the drawings and then we can move on to the next slide. So these, now we will go to improper fractions. An improper fraction is a fraction where the numerator a is greater than the denominator b. So can anyone come up with an example of this type of fraction?
Yes, I think let us have them right on the screen.
Oh, perfect. Yeah, that's a great idea.
Use that screen. Let us see. You first try it right on the screen. Like the way you have been annotating. Oh, yes, we can use the chat. Type in the chat as well.
Yeah, the chat is also possible. Then everyone can give an answer. That's easier than and I'm not sure if I can see the chat.
Are you able to see the chat, Lindy?
Yes, here I have the chat. 12 out of 6, 18 over 7, 10 over 5. Indeed, those are all correct examples. And I see some appearing on the screen as well. Very well. Perfect. So the numerator A must be greater than the denominator B. All perfect examples. That's great to see. Okay, so now we've seen some examples. I will continue. So I brought some examples as well, but you guys had excellent examples. So now my challenge for you guys is to shade 13 pieces out of 4. So I will present wait, so yeah, I have all the other, but we will start with example 1. So to shade 13 pieces out of 4, you notice I didn't brought 1 pie because that would not be sufficient. I brought 4 pies. So now it's up to you guys to fill in the pies where necessary. So I'm excited to see you guys work.
Okay, so let's shade. Please go on and shade. Let's shade.
Okay, perfect. I see already one drawing on the screen. Perfect. Okay, I see that the purple color is already finished. Does everyone agree with the purple coloring?
Yes.
Yes. Okay, so how many pieces are covered?
How many pieces are covered?
13.
13 indeed. So we started off. Yeah, perfect. I heard myself. Yeah. So we had a pie, and why did we divide the pie in 4 pieces?
Pardon?
Does
Linda,
anyone have an idea?
like they're asking for your pardon.
Oh, I will repeat my question. So we noticed that I brought 4 pies and they're all cut into 4 pieces. So can someone repeat why we cut it into 4 different pieces? Why do we have it in 4 pieces and not in 2 pieces, for example?
Because the denominator is 4.
Because the denominator is 4, indeed. So in the previous example, we noticed the denominator was 7 and we had 7 pieces. Or the denominator was 2, then we would have 2 pieces. So here, because we have a denominator of 4, we have to divide our object into 4 equal pieces, meaning that we need more than 1 pie. Okay, now we will move on to the next example. So can anyone predict how many pieces I will have in the second example? 5 pieces per object indeed. So I brought 3. I don't know if you can call it pies. I would call it pyramids because it looks more like a pyramid than like a pie. So I brought 3 pyramids with me, and all they all contain. Oh wait, and 1, 2, 3, 4. There's something went wrong. 1, 2, 3. So I hope you guys noticed that something went wrong in my slides because I don't have I don't have 5 pieces. I only have 4, so I will adjust the screen because this is wrong. We will take 4, then we can do the exercise. I'm really sorry for that mistake, but the the object I brought is only 4 pieces. So now it's up to you guys to shade 9/4. Yes, okay, perfect. I saw a solution. Okay, does everyone agree with this solution?
Yes.
Yes, indeed, perfect. So 9 pieces out of 9 pieces are covered. And again, we needed more than one figure to cover 9 pieces because we have an improper fraction. So now the final exercise is to shade 5 out of 3. And here I've done it correctly. So now I have objects with 3 pieces. So you can start and cover 5 out of 3.
Excuse me, can you?
Okay, I think we're finished. So I see that 5 pieces are covered, and I made it a little bit more difficult because I brought one piece that we don't need to use at all. It was to test if you guys were all following, and I'm really happy to see that you've done it correctly. So indeed, we shaded 5 out of 3 pieces. Perfect. So I hope now the proper and improper fractions are clear for everyone, so we can continue to the next slide. So we will see equivalent fractions. What are equivalent fractions? Equivalent fractions, they have the same value, and both the numerator and the denominator are multiplied or divided by the same number. So I brought an example with me. Here we actually go the other way around. So we've already done an exercise on making the simplest form. And here we're going from the simplest form, namely 2 over 3, to a more non-simple form, 8 out of 12. So all these fractions, they cover the same amount of the pie, although that the pieces of the pie have a different the pieces of the pie aren't equal. For example, a pie that is cut into 3 pieces and where 2 pieces are eaten, we notice that the pieces are quite large, while a pie with 6 pieces and 4 pieces are eaten, the pieces are smaller. And then even for a pie 8 out of 12, then the pie is divided into 12 pieces and someone ate 8 pieces. Those were really small pieces, but I hope everyone can see that the amount in total is the same. Like the purple the purple pieces, the pieces that are purple, are the same in all 3 the cakes, in all 3 the pies. So it means that those fractions are equal to each other. They actually have the same value. So can anyone come up with a fraction that 2 fractions that are equal to each other other than those presented here?
We can use the chat, type any 2 fractions.
Yes. So type in 2 fractions that are equal to each other, that are equivalent to each other.
So type in the chat. Those who can, you can even write.
Yes. So I see some great examples. 2 out of 4, 4 out of 8. Yes, very well. I think there's one wrong answer. Specifically the one from Kara and Makila. Do you guys see why that's not a equivalent fraction? You always have to think, can you multiply the denominator in the denominator or divide the denominator and the denominator with the same amount to become, so all the other answers are indeed correct. So perfect. I'm really happy to see this and to see that you guys can come up with an equivalent fraction yourself. Perfect. Okay, so I want to pay a little more attention. Perhaps one of them can tell me if they understood why it's wrong, but I see that the answer is already gone. So I think you already know why what you did wrong, but no problem at all. It's the first time you guys see an equivalent fraction, so I'm not surprised that for some people it might be a little more difficult. But perfect. I'm really excited to see that. So you've given perfect examples of equivalent fractions. So now the final thing we will see before we will start our exercises on the Kahoot quiz is the mixed numbers. So mixed numbers means that we have a whole number followed by a proper fraction. Can anyone repeat what a proper fraction is or type it in the chat as well? Also possible. What is a proper fraction? You can also give an example if you don't want to type it out. Give an example of what a proper fraction is. Anyone? A proper fraction? You already gave an example of a mixed number. That's a whole number indeed with a proper fraction. That's even better. So a proper fraction was a fraction where the numerator was smaller than the denominator. Here I see the denominator is larger than the numerator. That's also correct indeed. Perfect. Perfect. Okay, so now if you you can already start typing a mixed number. So that's a whole number followed up by a proper fraction. So type in any whole number and let it follow by a proper fraction. Perfect. Yes, I see AO, Barbara. Perfect. I will give you guys a little bit more time, but I don't think we have that much time left. Okay, so we will continue because I see that the time is ticking away very fast. So I brought some examples as well. So we have a whole number and then it's followed up by a proper fraction, very important, a proper fraction. The numerator is smaller than the denominator. And mixed numbers, it can be converted into an improper fraction and vice versa. But I don't think we will go into this more. That is for the next chapter. So let's go to the exercise. I hope you guys can see my screen still. So you can join through your cell phone or with a, so you can scan the codes, or you could just go to Kahoot, www.kahoot, and then you can fill in the code of the game. So let me know if anything goes wrong.
Yes. Lindy, kindly
Yes.
type in the chat. Type in the chat.
Yes, the number.
Yes, type in the chat the Kahoot.
I will do that. Wait. I hope the link works, and otherwise you just have to go to the site. So let me know if it works.
Have you is the link in the chat?
Yeah, normally the link is in, wait. I've done it to one of you. That's not correct. I'm gonna change it to everyone. I saw that only, and I could see my okay, now the link is visible to everyone, I hope. Okay, I see the first people appearing. Okay.
Like this. Does not work. Yeah,
Okay, I'm still waiting on everyone to join, and then we can start with the quiz.
Uganda.
Kenya.
I think we are there.
Yeah. So at the moment, I have 8 students, where 2 students, 3 student couples. So like, still people are joining. So let me know if I can start, that everyone can participate. If you can't join the quiz, but you can see it normally on the screen as well. So I hope for the people that can't join it through their phone or through their computer, they can just follow the quiz through the screen, and then you can solve the answers as well. You would just not be able to see your scores. So let us start. Now I see 10 people. Okay, I will start the quiz. So Roberta shades through over 7 of a shape. What fraction of the shape is left unshaded? So be aware, it's not what part is shaded, it's what part is unshaded.
I beg your pardon, the question?
Yes.
Linda,
Oh,
can you repeat the
yes.
question? Repeat the question.
The question is normally visible on the screen, no? Wait, I will try. Um, So the question was, Roberta, she shades 3 out of 7 of a shape. What fraction of the shape is left unshaded? So I brought a pie for you with 7 pieces, and 3 out of 7 were shaded. So how many are left unshaded? Perhaps the question went a little too fast. I will try to make it a little longer. I don't think I can show. So I'm really sorry that you guys weren't able to answer it. I think the timer went a little too fast, but the correct answer was 4 out of 7 pieces, since 3 out of 7 were shaded, 4 were unshaded. So now I will try to go slower, but I don't know if that's possible. So I will go to the next question. Is that fine for everyone?
Are you able to see the question?
Yeah.
Yes, Lynn, can you go to the next question?
Yes. Okay. So a cake is divided into 12 parts. Mac eats 3 out of 12 and Leo 1. What fraction of the cake is left? So we have one person that eats 3 out of 12 and one person that eats 1 out of 12. What fraction of the cake is left? Only 5 seconds to answer. Okay, so most of you guys got it correctly. Indeed, the right answer was 8 out of 12. So 8 out of 12 is still left. So how did we solve this problem? We knew that 3 over 12 were already covered and 1 out of 12 was covered. So in total, 4 out of 12 was shaded. So that leaves us with 12 minus 4, 8 out of 12 that is left. Okay, let's go to the next question. Let's see who ended up first. Marta and Abby, really good, well done. So we will continue. I'm sorry if it's a little too fast. I tried to adjust it, but it's not possible anymore. So be as fast as possible. So a park contains 20 spaces. There are 17 cars parked in the car park. What fraction of the car park is full? So what part of the car park is full? We know that there are 17 cars parked in the car park. And in total, we had 20 spaces. Last seconds. Okay. So most of you got it correctly. We know that we have 20 spots in total and 17 are used. So that means that 17 out of 20 spots are used, and that is the fraction of the car park that is full. Does everyone understand it? Some people indicated 20 over 17, but that's not correct because that would mean that there would be more cars than spots on the car park. Is that clear for everyone?
Yes.
Yes, perfect. Then we will continue. So I don't know how to pronounce it yet. I'm not sure if I've done it right. Very well done. So we will go to the next question. The same question. So a car park contains 20 spaces, but now I want to know what part of the car park is empty. So not what fraction of the car park is full, but what fraction of the car park is empty. Okay, perfect. Almost everyone got this one correct. So indeed, we know that 17 cars were parked. So 17 out of 20. So three spots were still empty. Okay, perfect. We will go to the next question since you all got it right, almost. So now, yeah, it's still on the top. Very well. Okay, let's go to question 5. Bob eats three out of 10 of the sweets in a pack. Sia eats another 4 out of 10. What fraction of the pack has been eaten? Very well done. Indeed, 7 out of 10, 7 over 10. So we know that Bob ate 3 out of 10, Sia ate 4 out of 10. So in total, 7 out of 10 has been eaten because 3 plus 4 is equal to 7. Next question. So I hope I stay in time because I think we have to close the lesson. So Adrian, very well done. Now you're at the top. So Now, the same question, but I'm not asking what fraction of the sweets is eaten. I'm asking what fraction of the sweets is left. Okay, so I see that some people indicated the wrong answer, 7/10, but 7/10 was the answer for what part of the sweets, what a fraction of the sweets were eaten. So now I'm asking what fraction of the sweets is left in the package. We know that 3/10 was eaten by Bob and 4/10 was eaten by Sia. So in total, 7/10 were eaten by Bob and Sia. So that means that only 3 sweets are left over in the package. So 3/10 was the correct answer. Okay, sorry, I'm going a little faster. So which diagram shows this improper fraction 7/2? 7/2. Okay, so I see that most of you guys got it correctly. Some were confused. So when you think about an improper fraction, you know that you have to divide it by the denominator. So the denominator is 2, so you have to divide your pi or your image by 2. So I divided the pi by 2, and then I took 7 pieces. So that's more than 1 pi. It are 7 pieces, so in total we need 4 pies. So answer 2, the yellow one, was correct. And I hope everyone sees what they've done wrong. The people that answered option 1, that's a fraction, that's a proper fraction, 2/7. But we're asking the improper fraction, 7/2. So I hope that's clear, and we will continue to the final question. Let's see, Lisa, very well done. Now you're at the top. So we will go to the final question. Which diagram shows the improper fraction 8/3? Perfect. Now everyone got it correct. Indeed. So we have an improper fraction with the denominator equal to 3. So we know we have to divide our pi into 3 pieces, and then we have to select 8 of them. So we have option red. The red option was the right one. So let's see who is the winner of this quiz. Adrian has a 3rd spot. Anna has a 2nd spot. And then we have 1st spots. Lisa, congratulations. Okay, so I will stop this quiz. And then I think the lesson is coming to an end. I'm looking at Stefan. I think I have to end the lesson here.
Yes, Linda, maybe you can now stop sharing your screen.
Yes, I will stop sharing. Okay.
Okay.
So I want to thank all of you to participate in this lesson. I understand that it's a little bit more difficult for me to teach you guys on a distance, but I hope you enjoyed it. I hope you enjoyed it all and you learned something today. Yes? Oh, so great to see you guys. Very nice. Have a great day. Okay, so nice to see you all. You did very well. I'm very surprised on how fast you guys got to know everything. I'm really excited. Bye-bye.